Okay, let's take a look at an example that uses iteration. We're going to use some for loops to do what's called edge detection on an image. Basically, it'll take a picture and turn it into something that looks like a pencil sketch. So we're going to start with this butterfly picture, and we'll load it the same way that we have before. So we load it in our setup method. Like that. And then in the draw method, all we have to do is actually display it. And I suppose we should set the size of the window to actually match the size of the image. Okay, so if we want to run this, we'll end up with our butterfly picture. And now what we want to do is implement our edge detection, and we'll make that so that it happens on a mouse click. So in my mouse clicked method that you guys have seen before, what we're going to do is we're going to step through every pixel in the image. Okay, so we're going to use nested for loops to do that. We're going to go across the width first, so we'll call that variable y, or across the height first, so y is going up and down, starting in the upper left and going downward. Okay, and we're actually going to go almost to the very end of the image, but not quite. You'll see why in a minute. Okay, and inside that loop, what we're going to have is another loop, and this is the one that goes across. And this one will go all the way across the image. Okay, now to do the edge detection, what we need to do is take the average colors of 2 pixels. A pixel specified by X and Y, and then the pixel right below that. And that's why the Y only goes to the next to the last pixel in the picture. Okay? So we can get the color of a pixel at a certain coordinate like this. So let's make our top color will be equal to the butterfly image, and we use the get method at these coordinates. And then our bottom color will be the pixel color at these coordinates. Okay? Now to find those averages, all we're going to do is get the red, green, and blue components of each color, add them together, and divide by 3. So the top average will be equal to the red value of the top color plus the green value of the top color plus the blue value of the top color divided by 3, and then we'll have the same thing for the bottom, the only difference being that we're using the bottom color instead of the top color. Okay? Alright. Then what we have to do is see if those are within a certain threshold value. Okay? So we're going to do that by comparing their absolute value of their difference. So if the absolute value of the difference of those two averages is less than some threshold value, and let's define that as a constant, then we'll do one thing, otherwise we'll do something else, and we'll fill those in here in a second. For right now, let's go ahead and put in our constant here so we could come back and change that if we wanted to. Right now we'll start with a value of 7. Okay. Well, if the absolute value is less than that threshold, then what we need to do is set the pixel at the coordinates x, y to be white. Okay, so we would say bfly.set x, y, and then we have to supply the color. Well, let's make those constants again so we don't have to continually create them. And we'll go make those constants here in a second. Okay. If it's not less than that threshold, then what we'll do is set the pixel at that coordinate to black. Okay, so now we make those constants here. Oops, that's got a syntax error, by the way. Put that int there. So final color white is what we get when we call the color creation method with RGB values of 255, 255, 255, and black will be the result of calling color on 0, 0, 0. Okay, so now what we should have is when we run the sketch, we still load our butterfly picture, and now if I click on it, it becomes a pencil sketch because of that edge filter. Okay, and by varying the value of this threshold, we get different results. If I make it higher, we end up with less detail, or only the most contrast items being included in the sketch. See how that has a little bit less detail in it? Or if we go the other way and set that to, say, 5, then we're going to end up with more detail. And there you go. Okay, you see some artifacts there in the background. So for this particular picture, a threshold of 7 seems to work pretty well. So there we go. There's our edge detection algorithm. Okay, so what this example illustrated here was the use of nested for loops. And in this particular case, we're going across, or down first and then across, which is backwards from how we normally do it. And that's why I keep messing it up. Okay, so we've got nested for loops, a little bit of calculation, and then an if statement inside the nested for loop. And that's an example of using the for loop for iteration.